Hello, this is omorganlabs.com. This is a rundown of review of my website. Um, Basically, I'm discontinuing the website. I don't get a lot of traffic to it, so this is going to be my online record of what the site it did look like. So on the first page, you see I have different pictures of my O'Morgan Labs TI-85 tutorials, and that's just a stock photo, and some different things, circuits, TI-84 video, little snippets, and another stock photo. Okay, so basically I want this site to be dedicated to engineering, physics, things like that, online tutoring. You see I have a donate button here. You can donate to the site if you wanted to. Let's see. Online tutoring. That was the main thing. Do like online tutoring and stuff. All right, so I have the engineering part, the physics, devices, space travel, online tutoring. None of these links are working right now for whatever reason. So I'm going to go up here and I'm going to go to the different ones. Okay, so first I had ESNs, engineering notes. These are things that I was going to like make papers on these different subjects: the compressed air rocket, water rocket, Tesla coil, travel guitar, different things like that. Um, oh yeah, the Russ Parnell maneuver. This was in that movie Martian, um, with I forgot his name. But the movie Martian, where the guy goes to Mars and he gets stranded and he makes his own little farm, his little potato farm, and the potato farm blows up and he almost dies, but he gets back. That movie. Anyway, I was going to do some calculations of what the Russ Parnell maneuver would actually look like. Firefly fireworks, those are drone fireworks. I was going to do a paper on that. I may still do a YouTube video on it. That's just an idea I had. Actually, I saw it on the Super Bowl one year. They had all the drones making like a light show. Okay, those are my ESNs that I wanted to do. And physics, I had broken it up into classical physics and modern physics. So classical physics, you would have Newton's law, F equals ma, things like that. Modern physics would have been relativity, Einstein's theory, all that good stuff. Modern physics, okay, quantum mechanics and things like that. Talk about the particles and the whole thing here is I'm talking about gravity and how gravity works and anti-gravity and the CERN experiment for the antimatter particle producing anti-gravity, but I'm saying that's not, I don't believe that anti-matter makes anti-gravity because gravity works the same way forwards and reverse. If you threw a ball up and it came down and you reversed it, like if you videoed that and reversed it, it will look the same. It'll go up and down. So that's my whole thing about the whole antimatter, anti-gravity. I don't think antimatter makes anti-gravity. Okay, there's that part. The engineering stuff. I was going to break down circuits, Ohm's law, Thevenin's theorem, battery supplies, how to make those, AC phasers, how to work AC circuits, and the flip-flop circuit. Fluids and thermal, I was going to talk about potential flow, Navier-Stokes, thermodynamics, things like that. Mechanical, that's the dynamics, statics, just the mechanical stuff, metallurgy, GD&T. Oh, here's my GD&T video, a link to it on YouTube, and it has 38,000 views now. But it's on the O'Morgan Studios website. That's supposed to be like my artsy fartsy website. This is my technical website. So this is my when I first was putting the website and stuff together. Yeah, I'm saying a lot. But this is just a this is not meant to get a lot of hits. This is, I guess, personal, just so I can see what my website looks like or did look like, because like I said, I'm gonna discontinue it pretty soon. Okay, I had this part about hypersonics. If you want a hypersonic jet, that's what you would need if you wanted to have an airplane that goes from the ground to space and orbit and comes back. You need to, it has to reach these hypersonic velocities so you can get into, there it is, Mach 15, which is still short of the Mach 22.5 low Earth orbit orbital velocity. So that's the thing. You want to be in low Earth orbit. So you have to be going fast enough. If you go fast enough, then the air starts to create so much friction that it heats up your aircraft. So okay, so I was going into that a little bit. Hypersonics, following some different things with the hypersonics. Okay, I think that was under space travel. Okay, space travel. Okay, rocket propulsion. I was just going to go over the basics of rocket propulsion. Um, the different concepts, the advanced propulsion concepts, right? The metallic hydrogen, advanced hydrocarbons, antimatter, matter rocket, A-bomb rocket, railgun, tethering in space, solar sailboat, the Sabre engine, which is like a mix of a gas turbine engine, a ramjet, and a hypersonic engine, I think. Earth magnetic repulsion. I don't think that works because the Earth field, magnetic field, is so weak. You'd have to have your a field so high that it would not be practical. Advanced propulsion concepts. I kind of had that as one little section that people could look at, and I would kind of keep everybody aware of that. Starship propulsion and time travel. I actually did a calculation for Einstein's time shifts when time shifts as you approach the speed of light. So I had this scenario of, okay, you're traveling 1 light year at constant acceleration, and you can say, okay, well, how many years have passed on your ship? That's tau. And then you can say, well, how many years have passed on the Earth? What is gamma and what is the final speed? Gamma and final speed, they are variables in your Einstein equation for time shifts. So there you go. Those are the equations. Use sinh and I think tanh. I don't know what that. But the since the hyperbolic functions, they are functions that plot parabolic or parabolas, parabolic shapes. Anyway, you use all this good stuff, and 1.3 years. It will take you 1.3 years on your ship to travel 1 light year if you were just continually accelerating for a year at 1 g. And Earth would have passed 1.71 years. Okay? So time would slow down for you on your ship. You would be 1.3, 1.7 minus 1.3, you'd be zero point 0.4 years younger than your brothers and sisters on Earth. But the thing is, it would take 1.71 years to do it. It's not like, okay, I'm not gonna get off on a tangent, but I believe that time dilation and time shifts, that's kind of like a biological thing. It's like when you put a piece of fruit in the refrigerator. Time always goes forward. It slows down for you if you approach the speed of light, but as far as events and stuff go, time is like constant. If okay, anyway, I'm not gonna get into that. But the gamma is 2. That's like I think your difference between your ship time and your Earth time. And velocity would be 0.87 c when you get there. And then I talk about the whole refrigerator thing and time travel. I don't think you can go back in time. I think time it goes forward. You can only slow down and stop time. And even if you could reverse time for you in a little time bubble, you reverse time, it will just reverse time for you, but time would still go forward. So your biological processes would reverse or something to that effect, and strange things would happen. But you can't go back in time and create time paradoxes. That was my take on that. Okay, anything else in space travel? Okay, I'm trying to wrap this up. Okay, Waypoint space stations. Okay, so this is the one that I really want to get into. Basically, having space stations uh, between here and Pluto. Okay, or just keep going, just keep making space stations and kind of stutter step your way into deep space. This would go on for like years and years, generations past me, and basically that's how we get into the stars. We have all these space stations, or what I call waypoint stations, rest stops in space, and you would go from one to the other. And there are different types of stations. You would have like food stations that make food, and I'm gonna make a video. I should make a video about this garage idea, parking deck, the parking deck farm idea, where you have micro microgreens growing on different levels. So you increase your surface area that you can farm on, right? Say if you had 200 square feet to farm on, but if that was in a parking deck, you could have like 10 levels. So that'd be 200 times 10. That would be 2,000 square feet of space or land you can grow things on. So anyway, that would be one station. And another station would be like a heating thermal station. Okay, you would have that way over here in Neptune, Jupiter, Saturn kind of area where it gets really cold and you don't really have a lot of heat from the sun. So you would kind of have to jump start it and have like another little sun there, and that station would just generate heat. So you could do other things like it's like a second sun, right? An artificial sun. And you keep going like that, and you would just go to the deep depths of space, and yeah, it'd be like a space journey. Asteroid mining, you can mine asteroids. That's uh, business adventure, business venture, not adventure. It would be an adventure if you space did space mining. Okay, a lot of stuff I was gonna put in this, or I was putting in this website that just didn't get off the ground. Didn't have a lot of traffic. MHD, magnetohydrodynamics. This could work, but you need a power source. And if some of my other ideas have panned out, maybe I can find a way to get to that power source where MHD propulsion would be viable. Orbital mechanics, terraforming, that's another idea of terraforming Mars, making it habitable to human life. That would be another big construction project. That's another thing. Basically, what you want is construction workers to to build all this stuff. So you need like construction equipment and things like that. I mean, when people think about space travel, they think about Star Trek and these clean cut people. But those aren't the people that you need in space. You need construction workers. You need those guys with the hard hats, with the with the radio and the lunchbox full of sandwiches. You need those guys to go and help uh, build uh, the space economy, right? You need like a Vanilla Ice and his DIY show, right? You need construction people that know how to build stuff, build build architecture in space. Okay, that's what way stations are, like architecture in space, or space stations in general. Okay, terraforming. Okay, yep. Okay, news updates. This is where I was gonna put, about the whole antimatter producing anti-gravity. I don't think they ever did it yet, but I went through my explanation of why I think that antimatter doesn't create anti-gravity. But if it does, then maybe there's something else out there. Okay, so that's that part about the whole anti-gravity thing. And I would also put something about the gravitational waves, how they were finally detected, and that validated more of Einstein's theory. And then this goes back to Morgan Studios here, the RT